Okay, so I got a couple of questions about these two problems from integration by parts homework 8.2. So what I do if I'm trying to find, um, I'm trying to identify u dv in the given integral, then what I try and do is find a dv that I can integrate. For example, in this one, if I look at this, if I look at the denominator, x squared plus 1 squared, if I have a x up top like this, x squared plus 1 squared, then I'm pretty confident I can integrate that, right? Because if I do u substitution and that's u, then du's up here. Okay, so I'm pretty happy I can integrate that. So that's what I want my dv to be. And that leaves me with what? Well, that leaves me with an x squared e to the x squared. And this is what I'm going to let be u. Okay, and dv would be this guy. All right, so see if that helps with some guidance here. I won't do too much of it for you. It's gonna, I mean, du is gonna require the product rule, right? But you should, here's the trick. If you do, let me do du, that would be x squared e to the x squared times the derivative of x squared 2x plus, and then I will take the derivative of x squared and leave e to the x squared alone. And then if I factor the common factor out, there's a 2 and x and e to the x squared here. There's a 2 and x and e to the x squared here. So 2x e to the x squared. And that should leave me with x squared plus, if you factor that whole thing out, 1. Okay, so that should be real helpful when you do the next step. The next step being applying integration by parts. Okay, if that's du, then you can get v by integrating this thing, x over x squared plus 1 squared. And if that's u and that's du, then you should be able to come up pretty easily with v. And if you apply your integration by parts, I'll stop there. Hopefully that's enough to work it out. Okay, so apply integration by parts. This other one works the same way. Again, the goal here sometimes for integration by parts is to say, all right, what can I integrate out of this thing? Well, like a simple integration. If I just look at that denominator, 5x plus 1 squared, the question is, what would I need up here in order for that to be easily integrated? And the answer would be, and unlike over here, we needed a power of x when you had a power of x squared here, right? Because the derivative of x squared is 2x. The 2 doesn't matter. We can deal with the constants. So the derivative of x is 1. So really, I want that to be my dv. That I can integrate, right? That's u to the negative 2 and shouldn't be an issue. So I'm feeling pretty good that I can find v if I let that be dv, which means u will be whatever else is left, right? And that's x e to the 5x. Okay, so that's going to be, and I'll just put dx here, and that's u. Okay, so if I apply my formula, let's do a little more with this one. Well, first let's find v. V would be the integral of 5x plus 1 to the negative 2 dx, which is equal to, yeah, you could do a u substitution. This one's pretty straightforward though. The power should be negative 1. The base should be 5x plus 1. And then I ask myself, all right, if I'm going to integrate this thing, or if I'm going to take the derivative of this, I need to get this. So it'd be bring down the negative 1, so I need a negative here. Take 1 away, I'd get that. And then if I'm differentiating, I'd be multiplying by a factor of 5, right? So I'd have to divide by that. And that's if I differentiate this thing, I should get this thing, right? Bring down the 1, you ended up with a positive. Take 1 away, you end up with your negative 2. The derivative of 5x plus 1 is 5, so the 5's would cancel out. So that should work. Okay. So I got u dv, and du shouldn't be bad. So let's see. Du will require the product rule. It would be x e to the 5x times 5 plus, leave x alone. I'm sorry, take the derivative of x, which is 1. And this one actually is pretty similar to this guy over here. You'll see the similarities as we go. That should leave me, if I factor out an e to the 5x, I get 5x plus 1. Okay, so I got everything I need. So my integral u dv equals uv minus v du. So that's going to be, if this is u and this is dv, then u, as I have written here, is x e to the 5x. V we found by integrating this thing, so that's really a fraction. The 5 is in the denominator, and this thing's in the denominator, and it should be negative. And then what do I need to integrate? V, and here's where some cancellation should happen, so let's see what happens here. So V is negative 1 over 5 times 5x plus 1 du, which is this, and this should happen with this guy as well. I just didn't do the rest of it, but e to the 5x plus 1, e to the 5x times 5x plus 1x, and now I'm in good shape, right? So this will be a plus in the end, and that's part of my result, and this is easy to integrate. Okay, so I hope that helps, but if you got questions, let me know.